Hello. Hello. Am I audible? Okay. So, in today's class, we will discuss some of the conceptual questions on the topics which we have covered in the previous sessions, like pointers, arrays, and we will discuss some programming questions as well. We will actually see how to think on the logic on basis of what we have studied till now. Like, we will not go to any hard level programming questions. We will just look at some simple problems, and we will see how it can be solved using the simple concepts which we have studied in these sessions till now. Okay, so first few questions will be just output based questions where we have to just tell what will be the answer of our code, and last three questions will be programming based questions. Okay, so let's start with question number 1. In question number 1, I have a main function, and inside this main function I am creating an array of size 5. After that, I am calling this function print array size, and I am passing that array into that function. After this, I am just printing the size of my array using size of operator. And if you look at this print array size function, it just prints the size of array again, right? So I've created an array, I've passed it into a function. This function prints the size of array, and in the main function as well, I'm printing the size of array. Okay, what do you think these two print statements will print. Okay, so I'm giving you 30 seconds to think on this, and then I will discuss the answer. Okay, so we have two print statements, right? At one statement, we are printing the size of array where the array was created, and at the another location, we are printing the size of array where the array was not created, but we have passed the array. Okay. Now, what will happen is, since this array stores 5 integers, so one integer is of 4 bytes. So 5 integers will be 5 into 4, which is 20 bytes, right? So the size of array printed here will be 20 bytes. Now, many students think that if array has 5 elements and we are passing that array in this function, then this size of array will also give 20 bytes, right? But actually what happens is, whenever we pass an array to a function, it's compulsory that you provide the size along with it as a separate parameter. In this code, I'm not doing that. I'm just giving the array in the parameter, and this function will just receive the address of first element. If you remember, our class of array, I told you array stores the address of its 0th index. Array stores the address of its 0th index. That means when I'm passing this array in the function, this particular function will receive the address of 0th index, right? And since it will receive the address of 0th index, when I will print the size of array, it will print the size of address. Any address in programming language is stored in 8 bytes. Address is stored in 8 bytes. Since we are passing just the address of 0th index, if I try to calculate the size of array here, it will give me 8 bytes and not 20 bytes, because array by default stores the address of its 0th index, and when we pass it to a function, that address is passed to that particular function. That's why I said whenever we pass an array to a function, we provide another parameter as size. It is necessary that we provide size as a separate parameter. Otherwise, this function will not know the size of the array, right? So this will print 20 bytes and this will print 8 bytes. Okay. So this was first question. Let's move to next. Next, we have a main function. We have array of size 4, and I'm trying to print this ARR along with this operator. Again, I'm giving you few seconds to figure out the answer and then I'll discuss. Okay, so this is very simple. As we discussed that array stores the address of its 0th index, and since the array stores address, we can say that it is a kind of pointer, right? And we know that when we use this operator along with a pointer, it acts as a dereference operator. It acts as a dereference operator. And what do we mean by dereference? By dereference, we mean that we go from address to value. By default, ARR stores the address of 0th index. Okay. And if we dereference that, that means we need the value at that 0th index. So what is the value at that 0th index? It is 2. So this will print 2. Okay. ARR stores the address of 0th index. If we dereference that address, we will get the value at that address. So we have the value 2 here. Okay. This was very simple. Let's move to next one. Again, we have a code. I have an array and I'm trying to print this thing. Let's take few seconds to figure out the answer and then we will discuss. Okay, so in this question, we have written this 2 square bracket ARR. Now we have seen ARR bracket 2 many times, like we write number inside the bracket, but here we are writing ARR inside the bracket. It might feel that we have written a wrong syntax here, but this will work perfectly fine. Why? Let's see. When we write this, what compiler does in the background is that it converts this in terms of pointers. That means it says that we need to go 0th index plus 2 jumps, and we need to find the value. So this particular thing translates to this thing. We know that ARR, this is the address of 0th index. Address of 0th index plus this denotes number of jumps I need to take to reach the correct address. I'm telling from 0th index take 2 jumps. That means this is the address, this is the 0th index. Here, from here I will take 2 jumps, 1, 2, right? So this resolves the address. This resolves the address of 2nd index. Now I need the value, so I have written a dereference operator here. We know that if we dereference the address, we get the value. So ARR is the 0th index plus 2 means I will take 2 jumps and I will reach the correct address. And then we will dereference that particular address to get the value. So we are dereferencing it to get the value 8. So this will give me 8, right? So this is how this particular syntax works. But if you know that in addition, the order of operands doesn't matter. If we write 3 plus 2 or if we write 2 plus 3, both are same, right? 3 plus 2 and 2 plus 3, both are same. Similarly, I can rewrite this particular thing as, so if I write ARR plus 2 or if I write 2 plus ARR, they both are same thing. That means if this get resolved to this particular expression, we can say that this expression can come from this part. If this word is, if this is how we write and this gets resolved to this particular expression, then we can say that this expression, which is the same as this expression, comes from this part. And that means if I write this or this, both are same. So this will print 8. Okay, so remember that when you write something like this, whenever you try to access a value in an array, the compiler in the background resolves this thing into this expression. It writes address of 0th index plus the number of jumps, and then we dereference to get the value. But in addition, we can change the order of operand. So if I write ARR plus 2 or I write 2 plus ARR, both are same. So if this can work, then this will also work. So both of them will give the same result and it will be 8. Okay. Next. Here I have two integers x and n. I am creating ptr1, which is a pointer to x, which is storing the address of x. ptr2 is also a pointer which is storing the address of n. After that, in x, I am doing ptr1 minus ptr2. And then I'm trying to print x. For the simplicity of this question, I am assuming the address of x to be this and address of n to be this. So this is the address of x and this is the address of n. Now think about this code and try to figure out what will be the answer. Okay, here we are trying to subtract ptr1 and ptr2. The value stored in ptr1 is this and ptr2 is this. That means I'm actually trying to do this, right? And many students will give the answer 4, which will be wrong. Why? It's because we are not subtracting the integer values. These are memory address. They are not integer values, right? They are memory address. And in case of pointer subtraction, we check how many jumps we will require to reach from one to another. So suppose if you notice, the difference between both of them is only 4 bytes, right? So if this is the one memory and this is the another memory, this is where 4 is stored, this is where 6 is stored, and this has 432 at the end and this has 428 at the end, right? I'm writing only last 3 digits. If you notice, one integer takes 4 bytes. That means this 4 starts from, or this 6 basically starts from 4 to 8. It will take 4 to 9, 430 and 431. These 4 bytes of address will be required to store 6, right? If 6 has an address 4 to 8, that means it starts from 4 to 8, but an integer takes 4 bytes. So it will take 4 to 8, 4 to 9, 430 and 431, 4 bytes to store the number 6. And after 431, we have 432. That means there is only a difference of one integer. There is only a difference of one integer, which is 4 bytes. The difference between both of them is 4 bytes, which is only one integer. So the answer to this particular code will be 1, because we are not subtracting the integer values, we are subtracting the address. These both are address. And in case of pointer arithmetic, we do the subtraction based on the data type. And if we check 428, 432, the difference is 4 bytes, which is of one integer. So the answer will be 1, not 4 bytes. Okay. So these type of questions are very common in the interviews. Students get confused in these type of questions very easily. So pointer arithmetic is very important concept which you can focus on for the interviews. Okay. Let's go to next question. Here in this question I have given you 4 options as well. In the main function I have created a character array, 2 integers I and j. In the for loop, I starts from 0, j starts from 5. Condition is if I is less than j. And here I have written an expression. And in the loop, I am printing this complete A array, right? Note that in this expression, I'm doing I++, which is post increment, and in this, I'm doing j minus minus, which is post decrement. Try to think what will be the answer for this particular question. The options are given below. Okay, so let's discuss now. I have this character array which has this string world. So world, which means 0, 1, 2, 3, 4. So the first index is 0 and the last index of the word is 4. And in case of character arrays, right? In case of character arrays, the last character is always a null character. That means we have one more character at the end, which we don't need to write ourselves in this case, but there we have another character which is a null character. Okay, so even if we don't write that null character, it will be automatically appended at the end. So what is the use of null character? The null character tells the compiler when to stop reading the string, right? So as when our compiler reads a string 1, 2, 3, 4, 5, 6, as soon as it encounters a null character, it stops reading. If I don't include this null character, then the compiler will not know when to stop, and it will print some garbage value as well. That's why this null character is very important. So in this case, we have these indices 0, 1, 2, 3, 4, 5, and fifth is for null character. If you notice, our j is starting from null character, which means I have I from here and j from here. Okay, so j is starting from a null character. And what I'm trying to do is, I'm trying to assign the value of j in case of I, which means I'm trying to bring all of them towards this. So first I will bring null character. I'm trying to assign the value from jth index towards ith index. So jth is currently at null character, so I'm trying to bring the null character towards front. And what will happen if I bring the null character towards front? As I told you, as soon as the compiler encounters our null character, it will stop printing or reading the string. That means if the null character come towards first, then it doesn't matter what is behind that particular null character, it will not read anything. That means if I try to print A after that, the first character it encounters is a null character. So even if I have something or anything after that, it will not be read and I will get the answer null. Okay, I will get the answer null because the first character I'm trying to put ahead is the null character. So I will get null in this case. So these were some of the questions, and now we come to coding questions. I've taken simpler problems to discuss those topics which we have covered in these sessions, right? So the first question is, we have to replace all zeros with ones. Okay, we have to replace all zeros with ones. So for example, if I have this number as an input, I need to return this particular number. So instead of 0, we have written 1. Instead of 0, we have written 1. Right? The logic is very simple for this particular problem, and it is built upon the logic of reversing a number. If you have ever written a code for reversing a number, then this problem is just an addition to that particular problem. So what do I need to do is, first we will figure out the logic. What I can do is, I can simply separate a digit, right? I can simply separate a digit and check if it is 1 or 0, like if it is 0 or not. Simple, right? If this particular digit is not 0, then we can directly use it here. And then if this particular digit is 0, then we will replace it with 1. If this particular digit is 0 or not, so we will write exact. If this is 0, we will replace 1. If this is not 0, we will write exactly that. Now, in the class where I taught operators, I told you a specific operator which can help us in separating this last digit, and that was the modulus operator. That means if I do modulus 10 of any number, if I do modulus 10 of any number, I will get the last digit, right? So this is fine, that if I have a number, I can do modulus 10, I can get the last digit, and I can even apply a simple check if that number is 0 or not. Now the thing is, I need to form that particular number again. Yani, that means if I want to form this particular number, how do I do that? How can I do that? Right? So if you notice, we can make this number with the concept which we studied in our nursery or first classes, which was the unitary method, right? In unitary method, or or I guess it was not unitary, I'm sorry, but we studied ones, tens, hundreds, thousands, right? We studied these concepts. Once this first number is ones, the second number is tens, the third number is hundreds, thousands, 10,000s, and so on. That means I can simply form this number by multiplying any digit with 10 to the power x. 10 to the power x, right? So if I do 1 into 10 to the power 0, I get 1. If I again do 1 into 10 to the power 1, right, I get 10. And if I add 10 plus 1, I get 11. So I got these two digits, and so on. I just need to use this particular logic in the loop, and I will be able to solve this problem, right? So let's erase some of these things and start writing the code. Okay, so this is my function signature. I need to return a new number, so I have taken a return type of int. I will be getting a number, so let's assume that number to be n. In this case, we will consider that number to be 20301 to understand our code. And let's start writing the code, right? What we need to do is, we need to first separate this particular number, right? So we will okay. We get the last digit in the x every time. Then I need to check if x is 1 or not. If x is equals to 1, in that case, I need to change that particular number, right? So now what I will be doing is, sorry, let's first write for 0, or if x equals to 0, right? In this case, we will change it, right? We will store our answer in a separate number which we are going to return here. Okay, so for that, what I'll do is, if x is equals to 0, that means I need to change that particular number. So I need 1 instead of x, instead of 0 basically. Instead of 0, I will be changing that particular number to 1, multiply by 10, or we can say simply, we can also write a power function. Right, 10 to the power I. You can, there is a math library in the C programming language which has which can calculate the power, but if you want, you can write your own function as well, right? So I have replaced 0 with 1, multiply by 10 to the power I, which we saw earlier, right? And then we need to add it to the previous one. So basically, when we find 1, we know that it will not be changed. But when we found 0, we know that we need to change it to 1, which we did here, and then we need to multiply it with 10 to the power something, right? So it should be something. So we write 10 to the power 1 here because this is the second digit. So 0, 1, 2, 3, 4, right? So 1 into 10 to the power 1, which is what we are doing here. But then we need to add it to our previous answer as well, the previous digit. So this is what we will write. Okay, we will initialize our answer with 0. We will initialize our answer with 0. So for the first time, it will be 0 plus something and it will not do anything, right? If the number is not 0, that means if the number is not 0, in that case, I need to use the exact number, right? If the number is 0, I was using 1. If the number is not 0, I will use that exact number. So same line, but I will use the exact number which I got. So if the number is 0, I will change it to 1. If the number is not 0, I will use exact same number. Okay. Now, what do I need to do is, I need to change this I as well, because we know that when we are moving towards left, this power of I will be changing. So we will do I plus plus one thing. And this whole part should be in the loop because we are doing it again and again. So this whole part should be inside a loop. So we have written while n is not equals to 0. So what we are doing is, when we have used this digit, we will remove it. Then we are left with 2030. When we are used this digit, we will remove it. Then we are left with 203, and so on. So we are actually reducing the digits. So at one point, this all will become 0. So my whole number will become 0, and my answer will store the actual number, right? So we are storing the value in our answer as well. So my n is becoming 0, and it will become 0 when I will do this n equals to n by 10, right? So if I do 20301 divided by 10, I will get 2030. If I do 2030 divided by 10, I will get 203. So this is how we are actually leaving the last digit every time. So this will also come in our loop. Right. Let's take a very small example. So if I have 203, suppose I need the answer 213, right? We have answer is equals to 0. Okay. We have answer is equals to 0. We will check if n is not equals to 0. N is not equals to 0. X is equals to n mod 10. This will give the last digit. So x is equals to last digit, which is 3. It will check if x is equals to 0. No, it is not. We will go to else. Answer equals to answer plus x multiplied by 10 to the power I. So we need to declare I as well, right? So we have I equals to 0. So answer equals to answer plus x multiplied by power of I. So answer is equals to answer plus 3 multiplied by 10 to the power 0 first, right? So what will happen? It will store 3 in my answer. It will store 3 in my answer. After that, I will do I plus plus. So I plus plus means I becomes 1. N equals to n by 10. Dividing by 10, that means this number now becomes 20. We will again check. Is n 0? No, it is not. We get the last digit. So this time x is 0. If x is 0, that means this if condition will be true, and we will do answer plus 1 multiplied by 10 to the power I. So answer will be, previous answer we had 3 plus we have 1 multiplied by 10 to the power 1. So this will be 10 plus 3, which is 13. That means if you see, we have formed number till this particular point. And in the same way, next we will get 13 plus 200. This will be the next iteration, and we will get 213. So this is the code for our this particular problem. Okay, let's move to next part. Check if a number is a palindrome or not, right? So this is again a similar problem which we have just covered, right? So if it is a palindrome, we will return 1. So what do I mean by palindrome? A palindrome means if I read the number from left or from right, it will be same. So from left it is 1030301, from right it is 1030301. It is same, right? So that is a palindrome. What do I need to do? I just need to calculate the reverse of this number, and if that is equal to my current number, this is a palindrome, right? So if I write the reverse of this number, it will be same, right? The reverse of this number will be same. And how do I calculate the reverse of this number? Again, the same thing. Separate the last digit and start forming the number like we did in the previous case. Okay. So again, we will just write our code something like this. So every time we get our last digit, we'll divide it by 10, and at one point of time this number n will become 0. So we will again use this particular condition only while n is not equals to 0. We will again get the last digit as n mod 10. Okay, we will again get the last digit as n mod 10, and we will create our reverse and we will initialize it with 0. So exact same code, nothing changes in this case, right? So what we are doing is we are just calculating the last digit, and on the basis of that we are just doing power of 10 of I. Okay, now in this case there are several ways to write this code. One of them is that we handle the I differently in this case. We handle the I differently in this case. The code can be same, but how we handle the I can be changed, or we can change this particular line. So if you see 230, 235 and I need to make it 532. So I will get 5 here, 5 should be multiplied by 100, 3 should be multiplied by 10, and 2 should be used directly. This is how I will form my number. So when I am getting my last digit, I need to ensure that the first thing I am getting should come towards left. And how will it happen? I can simply change the value of I, which can be a little bit tricky because you need to know how many digits are there. The simpler part can be if you change this particular logic, and if you first multiply your previous digit by 10, okay, if you first multiply your previous digit by 10, and then, so what will happen now? Initially my digit was 0, and 0 multiplied by 10 is 0, right? I need to just add my last digit here, so 0 plus 5 will become 5. So if I just write last digit, this should work perfectly fine, because next time initially rev will be 0, so 0 plus 5, rev will become 5. Next time rev will already be 5, so 5 multiplied by 10 plus the last digit, this will become 53. And the next time 53 will be multiplied by 10 and plus 2, this will become 532. So this multiplied by 10 will happen again and again. I just need to write like this. So this code will give you the reverse of any number. After this, you just need to match if reverse what we have calculated is equals to n, then we can return 1. And if it is not same, we can return 0. Right? So we are not using any new or very complex concept here. We are just using loops and operators. This is just loops and operators. Okay? So this is the second problem. Now let's move to third problem. For this, I will not write the code, but I will discuss the solution. I want you to try to write the code. I will give you a hint how you can write, and we will discuss complete solution first. So we want to reverse words in a string. Okay, we want to reverse all the words in a string. So for example, if the input is we enjoy our festivals, we need to return the output festivals our enjoy we. That means all the words are reversed. Okay. Now, if you think about this particular problem, there are obviously several ways to solve this. One of the ways, which is little bit simpler as compared to other ways, is that if we reverse this complete whole string. So if I write, so we have we enjoy our festivals. What we can do is we can start with I equals to 0, that means this particular position. We can start with j, which is at the last position, and we can keep swapping them and bring them towards this side. So I and j will be swapped, and then I will move towards this side and j will move towards this side. What will happen with this? This whole string will be converted like this: S L A V I T S E F. Then we have space, so we have space R U O. Then we have space. Then we will go get Y O J N E. Y O J N E. Then we have again space and E W. If we reverse complete string character by character, this is what we will get, right? But this is not the answer which we want, right? This is not the answer which we want. But if you notice, all the words are at their correct position. All the words are at their correct position. It is just that their characters are reversed, right? It is just that their characters are reversed. You can apply this same logic to individual words, right? So what you can do is you can write I, you can write j here, and you can start reversing them. If you I will move towards this side, j will move towards this side. If you start reversing them, you will get festivals here. Again, you can choose I and j here. I will move towards this side, j will move towards this side. You can again reverse. In this word as well, I will move towards this side, j will move towards this side. You can again reverse, and here as well you can reverse. So this is exactly what we wanted. So we reverse complete string character by character, we get this part, and then we repeat the same process for individual words. Now how do you identify where the word is starting and where the word is ending? You identify with the help of space. As soon as you encounter a space after a character, you know that your word is ended, right? So if I get space after this, I know that I can place j here, and then I can start reversing. I will again traverse, and as soon as I encounter space, I know that my word has ended. I can write j and I can start reversing, right? So this is the complete logic for this particular code. So I will just give you a hint how you can write. First, you will have your main reverse method, which will get string and size. Here you will start I with 0 and j is str, or you have the size, right? You will start with I0 and j size -1, and you will reverse complete string by calling this part. Okay, so you will simply do reverse. Okay, and you can also pass these indices. So you can pass str, you can pass I, and you can pass j. So for that, I will change the signature. So you are saying that I want to reverse my string from this till this point, and you can write the logic of reversing one time, and you can just call the function again and again. When you will do this the first time, this is the output you will get, right? This is the output you will get. After that, you can just write the logic to find the start and end of a word and call reverse. You just need to find the start and end of a verse, end of any word, and call this reverse again and again inside a loop, and you will be able to achieve this output. Okay, so this is the logic for this question. So if you see, there are many questions which you can practice on the basis of simple concepts as well. Even if we don't move to data structures, heavy data structures or complex data structures, there are many topics which you can practice, and there are many concepts which can be asked in the interview without data structures. So before you move to any advanced topics, you should be able to code simple problems like this, because even if these problems seem simple, there is a there is a good chance that you will make errors in writing these types of codes, right? And once you have practiced these, then you can move to data structures. So this is all for this class now, and if you have any doubts, you can share them in the comment section once your recording is available. Okay, thank you.